Great, it's recording now. Let's talk about trigonometric functions in general, right? Then the last lecture, I'll show you how to deal with trigonometric functions of acute angles, small angles, the ones whose measure is between 0 and 90 degrees. But now we're going to generalize this for angles of any size, okay? Of any size. So mathematicians, in order to achieve this, they set the angles on the XY coordinate system in a standard position, okay? So suppose you have an angle beta with any measure, right? Not necessarily an acute angle, right? Yes, any angle with an X, Y as a point on the terminal side of theta. Remember, when the angle is in a standard position, it starts always at the axis, at the x-axis, and then ends somewhere, right? So suppose this is the terminal side. X, Y represent the coordinates of an arbitrary point on the terminal side. And this X, Y, then they set this R, the distance from the origin to the point, okay? And this distance can be found using the distance formula. Remember, x minus 0, x squared plus y minus 0, y squared. Then you take the square root of that. That is the length for r, right? R equals square root of x squared plus y squared. Then mathematicians redefine the trigonometric functions in general as follows. Sine of theta is going to be equal to second coordinate y over r. Okay. Cosine of theta, x first coordinate over r. And tangent of theta, y over x, okay? Y over x. Great. Now, remember the other three trigonometric functions, cosecant, secant, and cotangent, they sort of come for free once you flip sine, cosine, and tangent respectively, right? Flipping or taking the reciprocal of sine, we get for cosecant r over y. For secant, flipping or taking the reciprocal of cosine, r comes up, x below, r over x. And for tangent, x up, y comes down here, x over y, right? There we have the 6 trigonometric functions, but now defined in general, right? Based on these coordinates. And therefore, notice that now it could be that some of these trigonometric functions could be negative, right? Because this x coordinate could be negative as well as this y coordinate, right? Because these are arbitrary points on the x coordinate system, right? Y coordinate system. So we gotta be careful now with signs for these trigonometric functions. However, I will give you a nice mnemonic device that will allow you to deal with that easily. So first, let me show you just as example based on these general definitions for our 6 trigonometric functions. The first example says find the 6 trigonometric functions of theta, which is this angle, right? Its terminal side falls on the second quadrant, right? And they give you this point on the terminal side, the one having coordinates minus 3, 4. Solution. All right. First, we have to compute our r. Remember, r is this distance from the origin to this point. And that is given by the square root of x squared plus y squared, right? But notice, this guy is our x, this guy is our y. So what we do is this square root of negative 3 squared plus 4 squared, right? We're going to compute this. But what is this? Well, this is the square root of negative 3 squared is 9 plus 4 squared 16 9 plus 16, 25, right? And the square root of 25 is just 5, right? 5. So we computed R easily, right? R. Very good, very good. So now we have this R, we have X, and we have Y. So we have all the ingredients for this formulas, right? So we go ahead and say, okay, let's start with sine of theta. What will be sine of theta? Well, Y over R. Y is 4, R is 5, right? So there we go, 4 over 5. Done with sine. What will be cosine? Cosine of theta. Cosine of theta is X over R. So X is -3 over R. R is 5. So -3 over 5, right? Great. Now, what will be tangent? Tangent of theta. Tangent of theta is Y over X, right? Y over X. So Y coordinate is 4. X coordinate is -3. So there we have tangent, right? Tangent. Now, the other trigonometric functions, cosecant, secant, and cotangent, they can be easily obtained or gotten from these three, right? Just by flipping these three, respectively. Flipping sine, or taking the reciprocal of sine, we get for cosecant of theta 5 over 4. Flipping cosine, we get secant, right? So 5 up here, -3 down here. Flipping tangent, we get cotangent, right? So let's take the reciprocal of tangent, -3 over 4. That is cotangent. Very good, guys. So as you can see, we got all the trigonometric functions, but now in general, right? In general, based on the coordinates of a point on the terminal side. And notice we got sine and cosecant positive, but cosine, secant, tangent, and cotangent, they are negative, right? So we're gonna be careful with the signs, right? Very good, very good. Well, so now, in order for you to easily figure out what are the signs of a trigonometric functions, right? Without thinking too much about it, mathematicians created this nice mnemonic device. That I'm going to show you now, that will easily allow you to compute or to figure out the signs of the trigonometric functions in each quadrant, okay? It goes like this. You need to memorize this sentence. All students take calculus, okay? All students take calculus. Now, looking at the first letter of each of these 4 words, A, S, T, C, you can set up a mnemonic device for you to figure out the signs of all trigonometric functions. You go like this. All students take calculus, counterclockwise. All right, now all means that in the first quadrant, all trigonometric functions are positive. Are positive, right? Positive, all of them. Students, the S for students, means that sine and its reciprocal cosecant, they are positive. The rest, negative, okay? It's a very nice mnemonic device. So this means that sine and cosecant positive, but the rest, cosine, cosecant, tangent, cotangent, negative on the second quadrant, right? As we saw here, right? As we saw here, these two positive, the rest negative, right? Second quadrant. What about the third quadrant? The word take, precisely the letter T, will tell us that tangent and its reciprocal, cotangent, will be positive. The rest of the trigonometric functions, the rest will be negative, okay? Negative. That's for the third quadrant. Tangent and cotangent positive, the rest negative. For the fourth quadrant, this letter C from calculus tell us that cosine, and its reciprocal secant, positive. The rest of trigonometric functions, negative, okay? Negative. So cosine, secant, positive. The rest, tangent, cotangent, sine, cosecant, negative on the fourth quadrant, okay? All students take calculus, a very nice way to figure out the signs of these trigonometric functions, right? So having this tool, we will focus just on the numerical value of the trigonometric function, and the signs will be given by this nice mnemonic device, okay? I will show you. All right, so now guys, time to practice. Let's try to practice here. For example, number 3 looks good. Let me make it bigger for you to see. Can you try number 3? It says find for this angle, the one having on its terminal side this point, negative 5,12, sine of theta, Hint, I will give you the hint, the definition of sine of theta using coordinates of a point on the terminal side. The definition of sine is y over r, where r can be obtained using this formula, right? Square root of x squared plus y squared. And what is x, what is y, professor? Well, this is x and this is your y, right? Try guys, try to find it. Find your r first, then with the r, you go ahead and compute sine of theta, right? Sine of theta. You may use your calculator in case you need it to compute r, right? Sometimes r will be a whole number, but sometimes may not be a whole number, so just be careful. I see that here they have presented the answer in exact form, right? And maybe I can draw a diagram here, maybe I help, right? The angle is located at 1, 2, 3, 4, 5 to the left, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 up here, right? Somewhere there. -5,12. This is the terminal side of the angle. There's a point there, this point. This is the angle, right? Yeah. Let's call it theta. Okay, let's do it together. Okay, let's do it together. So then I will ask you to do problem number 4. All right, so first step, compute this R, right? Compute this R. It's the first step. To compute this R, I have a formula, right? So R will be equal to square root of x squared, but x is -5, so -5 squared, plus y squared, but y squared is 12 squared, right? We gotta compute this somehow. What is this? Well, take your calculator, guys, take your calculator, and using this function square root, do this, -5 squared plus 12 square, right? Great. Came out whole number 13. Okay, 13. Let's write out 13 there. 13 here. And now, following the definition of sine, right? Sine of theta equal y over r. Y is this guy, 12. R, we just computed here, is 13. 12 over 13. 12 over 13. It simplifies, so this should be the final answer, right? You follow, guys? 12 over 13. Can you try this one now? Compute secant of theta, right? Hint, let me give you a hint. We know that cosine of theta using coordinates is x over r, right? Where r is this, r is square root of x squared plus y squared, right? We can compute cosine first, right? This is our x, this is our y. And then once you compute cosine, then secant is just the reciprocal of cosine, right? So you flip cosine. So, or you can just directly say this r over x. Can you try that? Try, guys. No questions, just let me know. Okay, guys, let's do it together, okay? Let's do it together. First, always you compute your R, right? It is R, this guy, using this form. All right, what is R? Well, R is going to be the square root of x squared plus y squared, but x is -3, so we're going to do -3 squared plus -4 squared, right? Okay, so now this is going to be 9 plus 16, 25. The square root of 25 is just 5, right? R is 5. Now, we know that cosine of theta is x over r. X is -3. R is 5. So this is cosine, right? Then secant is just the reciprocal of cosine. So it will be 5 over -3. Now, this type of negative fractions, mathematicians write them like this. They place the negative sign on the middle, right? -5/3. Very good, guys, for this guy, right? Follow? Good. Now, let's continue then. Let's talk about maybe one more exercise, and then we want try to do this, find tangent. Yeah, the coordinates are 7 and -3, compute tangent of theta. Hint, tangent of theta is y over x, right? Just use that directly. We don't need r for this one, right? Mm-hmm. Okay, guys, so let's do it together, right? So tangent of theta should be simply y, you take y from here, minus 3, over x, x is 7, and just place the negative sign in the middle, right? Negative 3 over 7. So this is clearly A, right? Very good, very good. Okay, now time to use our nice mnemonic device, all students take calculus, to figure out where an angle lies, okay? Let me go number 6, and then I will ask you to number 7, number 8, perhaps. All right, on number 6, it says, name the quadrant in which the angle theta lies. They give you this information, tangent of theta positive, sine of theta negative. Okay, so XY coordinate system, all students take calculus, right? Here, all trigonometric functions are positive. Here, sine and its reciprocal cosecant positive. Here, tangent and cotangent positive. Here, cosine and secant positive. So where tangent is positive? Well, it is positive here, right? Here on the first quadrant, but also on the fourth quadrant, right? On the fourth quadrant. Here and here. But now, where is sine negative? Well, here sine is positive, here sine is negative, and here sine is negative, right? So here and here. But now, not hard to see that these two statements are true here on the third quadrant, right? Quadrant 3. So then you say, okay, then the answer should be quadrant 3. Follow, guys? Use all students take calculus, the mnemonic device, and figure out your answer. It's not that difficult. Try to number 7. Try to number 7 on your own. Okay, this one. Try to do this. All students take calculus. Okay, go ahead. Try to figure out where sine is positive and cosine is negative. Right? Where? In which quadrant? I see in the chat. Gabriela. Very good. Excellent. Yeah, great, excellent, right? Yeah, it's not that difficult. Great, right? First, where sine is positive, sine positive. Well, we know that happens here on the first quadrant, right? Because all trigonometric functions are positive on the first quadrant here. But also here, right? Sine is positive on the second quadrant. Now, where is cosine negative? Cosine negative. Well, here, right? The second quadrant, only sine and cosecant are positive, the rest negative, right here. But also, cosine is negative also in the third quadrant, right? Because only tangent and cotangent positive. So here and here, but where both things happen, where these two are true? Well, here, right? Not hard to see that quadrant 2, right? Excellent. Yeah, one more here, and then we will move on, okay? We will move on to talk about probably reference angle. So can you try to do this? In which quadrant cotangent is negative and cosine positive? Hint, all students take calculus. Use this because we're gonna use this next to figure out the sign of our trigonometric functions, okay? So go ahead. Yeah, and if you have questions, just let me know, okay? Yeah, this one is a little bit tricky. Okay, let's do this together, okay? Number 8, where cotangent is negative. Well, here all positive, here cotangent negative, right? Second quadrant. But not only there, right? Here tangent and its reciprocal cotangent positive, but here is cotangent negative, right? It could happen in the second or in the fourth quadrant. But now, where is cosine positive? Cosine positive. Cosine positive here on the first quadrant, right? But also cosine positive here on the fourth quadrant, right? Because cosine and its reciprocal secant are positive. So where these two statements are true, not hard to see on the fourth quadrant, right? Quadrant 4. Follow, guys? Quadrant 4, 4, 8. Excellent, excellent. So let's move on then. Let's talk about now what mathematicians call the reference angle, okay? Yeah, this one you can do it at home. It's easy. Let's talk about this, the reference angle. What is the reference angle? Well, remember in the previous lecture, when we talk about trigonometry of acute angles, right triangle trigonometry, we were working with small angles, acute angles, angles whose measure is between 0 and 90 degrees, right? So mathematicians realized that if somehow we figure out a way to represent any angle with a reference angle, which is going to be an acute angle, things should be easy for us to work with, right? So if you can represent any angle with a acute angle, then since we know what to do when the angles are small, then we should be good to go. So that's the idea behind this definition, the reference angle. Let theta be an angle in a standard position, any angle of any size, right? Its reference angle is the acute angle. Very important word is, right? It's an acute angle, small angle, theta prime, formed by the terminal side of theta and the x-axis. So it's an acute angle that you can always extract from any angle, right, of any size, right? It's like a representative, a small angle that we can work with. Now, for each quadrant, there is a formula to get or to compute this reference angle. For example, if they give you an angle on the first quadrant, then following the definition says the reference angle is the angle formed by the x-axis and the terminal side, right? Terminal side, which is this, right? This is the acute angle formed by the x-axis and the terminal side. So it's just this angle itself, right? Itself, when the angle is on the first quadrant. So theta prime in the first quadrant itself. No need for a reference angle really, because the angle is already an acute angle, right? Now, however, when you are on the second quadrant, it's going to be a formula that you will have to use to get your reference angle. Again, following the definition says the reference angle is the angle formed by the x-axis and the terminal side, right? Terminal side is, right? And you may say, Professor, there are two angles there. This angle and this angle. Which one? The acute angle, the small angle, right? It's the acute angle formed by the x-axis and the terminal side. This is small angle. Now, when you look at this figure, now hard to see that this theta prime, this reference angle, will be equal to what? 180 minus the angle given, right? 180 degrees minus the angle given. This gives you your reference angle for the quadrant 2 formula here. Next, what if they give you an angle on the third quadrant? Well, again, if your angle is on the third quadrant, this would be the terminal side, right? Follow the definition, right? The definition says, okay, the reference angle is the angle formed by the x-axis and the terminal side, right? Is the acute angle formed by the x-axis and the terminal side. So it's going to be this angle, right? This one. Mm-hmm. Now, this angle clearly is the given angle minus 180, right? This is what the formula says. Theta minus 180 for quadrant 3. That's how you get your acute angle, your reference angle. For the fourth quadrant, if your given angle is on the fourth quadrant and you are looking for a representative, an acute angle that could represent this big angle, follow the definition of reference angle, right? The reference angle is the angle formed by the x-axis, always the x-axis, and the terminal side, right? And you may say, Professor, I see there two angles formed. Always take the small angle, the acute angle, right? That's according to the definition, the reference angle, right? This. All right, so this will be a full revolution, 360 degrees, minus the given angle, right? The 360 minus theta. All right, guys, so we have 4 formulas to compute our reference angles, or you can draw the diagrams from there. Naturally, you will know what to do, right? Or follow the formula. Okay, so examples here. Example 1. Find the reference angle of 300 degrees. 300 degrees. Okay, this 300 degrees falls in which quadrant? Well, if you draw a little diagram, not hard to see. If you draw this XY coordinate system, not hard to see that this is 90, 180, 270, 300 might be somewhere over here, right? This is 360, so this is 300 degrees. Now, notice this 300 degrees angle, if we follow the definition, right, it has a reference angle, or for its reference angle, this. The angle formed by the x-axis and the terminal side, right? This should be the reference angle, right? So clearly it's 360 minus 30 degrees, right? And 300 degrees. So this is what the formula also says, right? So either by drawing the angle on an XY coordinate system or by following directly this formula, you should be able to get it. So this will be 360 degrees minus 300 degrees, and that is 60 degrees, right? Follow, guys? 60 degrees. That's your reference angle, theta prime. All right, great. So this is theta prime, right? 360 degrees minus the given angle, 60 degrees. Great. Another example here. Suppose they give you the angle 130 degrees and they ask you to figure out its reference angle. Well, again, it's a good idea to draw the angle, to set the angle on the XY coordinate system. 130 degrees is here, right? The second quadrant. Now follow the definition, right? For the reference angle, the definition says the reference angle is the acute angle formed by the x-axis and the terminal side. The acute angle formed, right? This angle. This angle is clearly 180 minus 130, right? Or you can just follow the formula that I have given here, 180 minus a given angle. So this will be, this is your theta prime. The prime will be 180 degrees minus 130 degrees is 50 degrees, right? 50 degrees represents the angle 130, right? An acute angle. That will help us. So 50 degrees here. What about 250 degrees? Suppose they give you this angle 250 degrees. That angle, no hard to see, is here on the third quadrant, right? When set on a XY coordinate system, 250 degrees. Now, what is its reference angle? Well, you can follow the formula here for the quadrant 3, right? Which is a reference angle, given angle minus 180 degrees. Or if you forget the formula from here, right? Follow the definition. What is the reference angle? That is the acute angle formed by the x-axis and the terminal side of the angle, this angle, right? Clearly, that is going to be 180 up to here, 250 up to here. So theta prime has to be equal to 250 degrees minus 180 degrees, right? And that is just 70 degrees. 70. So theta prime 70 degrees, right? Right? Either from the graph or following this formula you can get it. Okay, guys. Now, let's talk about a fact that will help us to work with these reference angles. The trigonometric functions of an angle and its reference angle are the same except possibly for the sign. They are the same in absolute value. So let me explain this fact for you. This is telling us that numerically, the numerical value of the trigonometric functions are the same for the angle and for its reference angle, right? The sign may not be the same, but we don't have a problem with the signs for the trigonometric functions because we have this mnemonic device, all students take calculus, right? We can take care of the signs using that. So we're gonna use this fact and the reference angle to go over different exercises. Let me explain to you now example 2, which says this, the following. Giving sine of theta equal 4/5 and tangent of theta negative, find cosine of theta and tangent of theta. All right, so let me explain to you how we can deal with this. Okay, so I know that sine of theta is 4/5, which means I know that this guy is positive, right? Positive. We're gonna figure out where theta is first. Now, I know that tangent of theta negative, right? Negative. 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 So remember those questions that we were working on? Here, sine of theta positive, tangent of theta negative. So where is this angle then? In which quadrant? Let's see. Where is this guy? Well, if we follow all students take calculus, right? On the first quadrant, all angles have positive trigonometric functions. So sine positive here, but also here, right on the second quadrant, according to all students take calculus. Tangent negative where? Well, on the second quadrant, right? Because only sine and cosecant are positive, but also on the fourth quadrant, right? Yeah, but where these two statements are true, clearly on the second quadrant, right? So this means that our angle, then our angle is on the second quadrant, right? So let's write here. Then theta is in Q2, right? Q2, quadrant 2, somewhere. So therefore, then we can represent our angle easily here as follows. Well, then we can say, okay, since theta is on the second quadrant, we can say that, theta might be somewhere here, right? Theta. Very good. Now, the next step is this. Theta is somewhere here. I'm going to take an arbitrary point on its terminal side and do this. I'm going to attach this right triangle, okay? And since I know that sine is opposite over hypotenuse, let this height be 4 and let this length be 5. Follow, guys? So I'm focusing all my attention to this little triangle, right? Great. Now, in that triangle, I don't have the base. I don't have the base, but that shouldn't be a problem because I can complete the base, right? By saying, okay, this could be B. Don't worry about the signs because with all students take calculus, we will find out the sign of the trigonometric function. But in this triangle, then, use the theorem of Pythagoras and find the value of your B. 16, B squared equal 25, B squared equal 9. So B is square root of 9, B equal 3, right? 3. So once you get the value of B, quickly replace it here. And we have completed the triangle. So we can now answer the questions, right? They want us to compute cosine and tangent, right? So let's do that. Cosine first, cosine, the angle theta will be what? I know that cosine of theta prime, which is this, the reference angle, right? Theta prime, the reference angle is gonna be this, adjacent 3 over hypotenuse 5, right? But now I want the cosine of theta, right? This is the cosine of the reference angle. Now, according to the fact that we saw, the value of these two cosines should be the same, right? 3/5, 3/5. Leaving a space for the sine, The sine will be determined by all students take calculus, right? Take calculus. Any of you guys could tell me what should be the sign for this cosine function on the second quadrant according to all students take calculus? Anyone could tell us? Is it positive or negative, the sign of cosine? I see. Chat, some activity there. Gabriela, excellent, Gabriela. You made my day. Negative, right? Negative. Yeah, because only sine and its reciprocal cosecant are positive. So this is negative, right? So then you put negative there. You see, far-wise, negative. Right? The value is given by the reference angle, but the sign by all students take calculus. Excellent. Now, the other one. They want tangent also, right? Tangent. So you start by computing tangent of your reference angle, which is going to be opposite 4 over adjacent 3. And then tangent of the actual angle, right? The one on the second quadrant will be what? The value, the same, 4/3. But for the sine, leave on a space. according to all students take calculus, what should be the sign of the tangent function on the second quadrant? Anybody could tell us? Positive or negative? Positive or negative? You can write it in the chat. According to all students take calculus, the function tangent on the second quadrant, is it positive or is it negative? Which one? Okay, let's think about it together, right? On the second quadrant, only sine, let's write it here, only sine and its reciprocal cosecant are positive, right? The rest negative, So it means that tangent in particular has to be negative, right? Because only sine and cosecant positive on the second quadrant. So this one negative. Yeah, very good, guys. So this guy negative, right? And then this done. These are the answers, right? This and this. Very good. You can see, guys, the reference angle helps to compute the value of the trigonometric function. And with all students take calculus, we complete our task, right? Of finding the trigonometric function of any angle. Yeah, very good, very good. I have a question. Yeah, the triangle. Yes, yes. Yes, very, yeah, we use that. We don't have R here, right? We actually could, R could be 5. R is known. What I'm trying to do is here first, look, the angle is on the second quadrant. It's not a small angle to work with, right? The angle could be in the second quadrant, could be in the third quadrant, could be in the fourth quadrant, right? First, we reduce this angle to its reference angle. Then I can work with the reference angle, right? In a small triangle, right? And then once I get my values using all student take calculus, I compute the signs, right? Yeah, it's better now, Gabriela? Yeah, the reference angle is just to work with the acute angle, right? So because otherwise the signs could be difficult to determine, right? Yeah, that's the whole idea. Yeah, very good. Yeah, you're welcome. Happy to help. All right, great. So now let's move on. Let's take a look at some examples, right? Let's try to work. You guys should work on some examples here. Yeah, first we're gonna find some reference angles, and then we're gonna do some exercise. Okay, reference angles. Now, yeah, we did this. Can you figure out the reference angle of this guy, 131? Let's do this first. Do this. Find the reference angle, make it bigger. Yeah. Reference angle of 131 degrees. Hint, 131 degrees is on the second quadrant, right? And there is a formula for the theta prime on the second quadrant, right? So I gave you a formula, and that formula is 180 degrees minus the given angle, which is this guy, right? So try to apply this formula, figure out the reference angle for 131 degrees. Yeah, this is the reference angle. Theta prime. I see. Some activity in the chat room. Let's see. Hello. Excellent, excellent. You made my day. Very good, very good. Very good. You got it. Excellent, excellent. Great. Yeah, applying the formula, see, the angle, the reference angle is the angle, the acute angle formed by the terminal side, and the x-axis, the small angle formed, right, is this, right? It's clearly 180 minus this guy, right? So theta prime equal 180 degrees minus 131 degrees. And this difference, if you use the calculator, 49 degrees, right? So this guy, excellent, excellent. Very good. Can you try to do the same with this guy? This went over. Yeah, I'm gonna do number 11, so for you to have an idea, okay? So how you can do this. Let's do it together. Sometimes the angle may go over 360 degrees, right? Such as the case of this guy, right? 428, right? So so somewhere here probably, right? This guy is too much. But what do we do when the angle is greater than a full revolution? We have this other technique. It's called coterminal angles. So we can always subtract as much as we want 360 degrees, right? Or multiples of 360 degrees and get a new angle. These are coterminal angles, right? Coterminal angles. Coterminal. And trigonometrically speaking, these two angles are basically the same. So 428 degrees can be substituted with 68 degrees, but this 68 degrees now is on the first quadrant, right? In the first quadrant. So therefore, it's theta prime, its reference angle is just itself, right? Itself. Follow, guys? Itself. So this one, right? Yeah, so in case it's over 360, subtract 360 degrees. Now, there is a negative angle. What to do? Yeah, this is a special case too. Let me explain. If they give you a negative angle in the homework, I think I've seen one. Yeah. How you get that reference angle of this negative angle? Remember, negative angles are formed by rotation clockwise, right? This way. Yeah. So for these angles, advice, guys, follow the definition. The definition of a reference angle is the acute angle formed by the x-axis, this always, and the terminal side. This is the terminal side, right? It's the acute angle formed by the x-axis and the terminal side. That acute angle formed is this guy, right? It's this guy. So this guy, positive, always positive, the reference angle, right? So theta prime equal 44 degrees. You follow, guys? Tricky, but doesn't have a formula really, right? But you gotta follow the definition for negative angles. 12. Very good, very good. Now let me ask you to do this. Let's see if you can do this. Yeah, this one you can do it at home. Reference angles for this. Yeah, I think we can do this perhaps using the reference angle. Find the value of tangent of 750 in exact form, right? Exact form, yeah. Let me give you an idea for number 13, and I would like to do number 14. For 13, they want sine of 405 degrees, right? 405 degrees is greater than 360, right? Degrees, a full round. So whenever that happens, immediately extract this full round 360 from 405, subtract, right? And you get a new angle, which is within a full revolution 45 degrees, right? These two angles are coterminal, right? Coterminal. So trigonometrically speaking, they are the same. So this sine of 405 degrees is exactly the same as sine of 45 degrees, right? But remember, I gave you this guy, right? Sine of 45 degrees, recall. This guy is just the square root of 2 over 2, right? I gave you a table. Today we will summarize this on the unit circle, but we have this, so then it's just this, okay? So whenever the angle goes over 360, subtract 360 degrees, you will be in a better position. So let's continue. Okay, suppose they ask you to figure out tangent of 750 degrees. How you do this? Tangent of 750 degrees. The angle is huge, Professor. Yeah, remember when the angle is bigger than 360 degrees, feel free to subtract 360 degrees as many times as you need it, right? This is going to be 0. This is going to be 9. This is going to be 390, right? But now, this 390 is still big, still bigger than 360. So subtract again 360. Remember, you can take away these full revolutions as many times as you wish, and the result should be always a coterminal angle, right? Look, I got 30 now, better, right? What is important here, guys, is that you notice that these two angles, 750 degrees and 30 degrees, are coterminal angles, meaning trigonometrically speaking, the same. Tangent of 750 degrees, exactly the same as tangent of 30 degrees. But tangent of 30 degrees, recall I gave you the trigonometric functions of this angle 30, right? Remember sine of 30, 1/2, cosine of 30 degrees, square root of 3/2, and tangent of 30 degrees is just the square root of 3/3, right? Square root of 3/3. So this is what we need here. So square root of 3/3. That's it. That is 414, right? Very good, guys. Now, before moving on and going over the exercise I'm going to ask you to go over, let me explain this one too. Sine of 5 pi. Sine of 5 pi over 3. Or perhaps I could let you try this, right? Try this. Hint, convert to degrees. Convert to degrees. And then see what you get. And then figure it out, okay? Either using the facts that we were using before, or using a coterminal angles or reference angles, right? Yeah, remember to convert, you just have to multiply this angle, which is in radians, by this factor, right? Pi radians, 180 degrees, right? This is how you convert. Yeah. And once you do this, get the angle and then work with this angle in degrees, right? And try to figure it out. Okay, guys, let's do it together, okay? Let's do it together. When you convert 5 pi over 3 radians to degrees, after canceling pi, multiplying 5 times 180 divided by 3, 3 into 180 is 60, 60 times 5 is 300, so 300 degrees is the result of this, right? You can get it with a calculator as well. Now, I am after sine of 300 degrees then, right? Good. Now, this 300 degrees falls within a full revolution right here, right? And it has a reference angle. What is the reference angle, Professor? Well, it's the acute angle formed by the x-axis and the terminal side. It's this angle, right? And I even gave you a formula for this. This is just going to be like 360 minus 300, right? 360 degrees minus 300 is the angle that is given minus subtracted from 360, right? Yeah. is this. But what is that? Is 60 degrees, right? 60 degrees. So 60 degrees is the reference angle, right? Reference angle. Reference angle. Okay, great. We got the reference angle. So this guy will be the same as the sine of the reference angle, except possibly for the sine, right? So it will be sine of 60 degrees. I'm leaving, notice, a space here for the sine, right? I don't know what the sine is going to be, but sine of 60 degrees, I have, right? Recall, sine of 60 degrees is just, remember I gave it to you, and soon we're going to summarize this on the table. Sine of 60 degrees is a square root of 3 over 2, right? Recall. Now, this is this part, the square root of 3 over 2. But now, what is the sine? Anybody could tell us, according to all students take calculus, all students take calculus. This angle is on the 4th quadrant. What should be the sign here? Positive or negative for this trigonometric function sine? For sine, the trigonometric function sine, is it positive or negative on the 4th quadrant, according to all students take calculus? Anyone? The hint, look at the letter C, right? C tells you that cosine and its reciprocal secant are positive. The rest of the trigonometric functions are negative, right? So sine is only positive here and here, but it's negative here, right? So this should be negative. You follow, guys? Negative. So negative square root of 3 over 2 should be the answer for 15, right? You follow, guys? Yeah. Try to remember this for your homework. All right. Enough with these examples. Now I want you to try this, guys. This one. Find the exact value of the indicated trigonometric function of theta. Okay, secant of theta equals 3 over 2. And theta is in quadrant 4. Find tangent of theta. Yeah, as a hint, I can give you this information. We don't have to figure out where the angle is, because they are saying there that the angle is on the 4th quadrant, right? In the 4th quadrant. So the angle is here, somewhere there, right? This is theta. Hint, try to work with theta prime, the reference angle, right? The angle formed by the x-axis and the terminal side, which is this. This is theta prime, right? Try to work with this theta prime. Hint, form a triangle there. And use this information, right? Secant 3 over 2. Remember, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, right? So this should be hypotenuse over adjacent, right? Over adjacent. So the hypotenuse should be 3 and the adjacent side should be 2 for the reference angle, right? Try to complete this. A, use the theorem of Pythagoras. Complete this, find A, and then with A, you can figure out tangent, right? And together with all the students, take calculus for the sine, So try that, guys. Then we will move on. So you're gonna work on this triangle. The one containing your reference angle, right? The reference angle is inside this small triangle. Mhm. Sometimes the students, when I do this, they ask me, Professor, should we worry about the sign of this A? No, just work with A positive because the signs will be taken care of by all the students take calculus. Don't worry, just compute A as a positive amount, figure out the value of your trigonometric function tangent, and then the sign of the tangent function on the fourth quadrant will give you in the all students take calculus, right? Mhm. All right, guys, let's do it together, okay? Do it together. I'm going to find A first by following the theorem of Pythagoras here. A squared plus 2 squared 4 equal 3 squared 9. Subtracting 4 in both sides, A squared equal 5. Taking square root of sides, A equal square root of 5, right? This is A. Great. Now once you have your A, then quickly put it there, here. This guy equal square root of 5, right? Yeah. So now I can find tangent of theta, right? Tangent of theta, but finding first tangent of theta prime, tangent of the reference angle. Tangent of the reference angle will be this guy, square root of 5, opposite over adjacent 2, right? 2. But then tangent of the actual angle, right, will be the value the same, square root of 5 over 2, but perhaps the sign not the same. So the sign, we have to figure it out. What is the sign of tangent of theta on the fourth quadrant, right? But for that, guys, not a problem. I have this nice mnemonic device. All students take calculus. Take calculus, right? So according to all students take calculus, what should be the sign of this tangent function? Anybody could tell us? All students take calculus. Calculus. Is it positive or negative, right? Aha. Gabriela, yeah, excellent, excellent. Yeah, you made it negative, right? Look, only cosine and let's write it here, right, to help understand this nice name. Only cosine, the C, this letter says that only cosine and its reciprocal secant, these are positive on the fourth quadrant. The rest negative. So in particular, tangent negative, right? Negative. So it's going to be negative. That's it. So therefore, the answer should be this. Excellent, guys. Excellent. Very good.